In 1916, Gustav Holst completed a magnificent musical suite entitled The Planets. It required a large symphony orchestra accompanied by a women's choir. 60 years later, Isao Tomita created an electronic version of The Planets based, in part, on the Holst score. The Tomita Planets uses no acoustical instruments and is performed by one man. During more than 3 decades, a unique collaboration developed between Earth-bound scientists and automated spacecrafts. As a result, we've learned more about the Sun and its family of planets and moons than was known in all human history. All great journeys into space begin with a liftoff, and ours is no exception. Our first destination has been the subject of 100 years of science fiction and fantasy. The Red Planet, Mars. Glowing like a red ruby in Earth's skies, there was something almost fearsome about Mars. To the Romans and Greeks, it was the god of war. To others, it was the red eye of the devil himself. 19th century astronomers, like Percival Lowell, thought they saw lines that crisscrossed the surface of Mars. Italian astronomer Giovanni Schiaparelli actually drew maps of Martian canals and oases. This led to fanciful legends about an advanced civilization that had built the canals to irrigate its desert planet. In fact, billions of years ago, Mars once had an abundance of liquid water. But the thin atmosphere allowed it to evaporate, or perhaps it was absorbed. Mars clearly needed closer investigation. Earth-based telescopes couldn't provide the detail required for study. In 1976, 2 Viking spacecraft were sent to Mars to gather more information. On making orbit, the spacecraft were programmed to communicate with Earth. Ground controllers ordered the Vikings to deploy landers. Equipped with a heat shield, the landers would finally parachute to the surface before firing braking thrusters. This is Mars, not the home of some fantastic civilization. A lonely desert, populated by rocks. Experience a Martian day. The night, colder than Antarctica. The noontime temperature seldom gets above freezing. Experiments were carried out to determine if life existed on the Martian surface or just beneath. The results were negative. Not surprising, really. In this frigid, arid desert, how could life gain a foothold? Especially with monster dust storms that ravage the entire planet. This is a computer-simulated flyover of Mars at over 200,000 miles an hour. The Valles Marineris below is a great canyon system that would stretch from New York to San Francisco. Mars has many features larger than those found on Earth. Here we pass over the Tharsis Montes, giant volcanoes that dwarf Mount Everest. Olympus Mons to the northwest is over 80,000 feet tall. Perhaps someone alive today will be the first to climb it. This frost is actually frozen carbon dioxide and water ice. On Earth, carbon dioxide remains a gas. We exhale it whenever we breathe. This is Mars. From the desert wastes of Mars, we journey to the brightest star-like object in the heavens, the Roman goddess of love, evening and morning star, Venus. As little as half a century ago, Venus was thought to be a twin of Earth. Being nearly equal in size, scientists wondered if it might be much like Earth, only warmer, perhaps even tropical. 1989. The Magellan spacecraft departs Earth. Venus is covered with an extremely dense, cloudy atmosphere. No human eye has ever seen the surface. Magellan carried with it equipment to see through the clouds and map the planet. Here are some actual time-lapse pictures of the cloud layer, which rotates around the planet every 6 days. Venus itself takes 243 Earth days to make a single rotation. Magellan fires its braking thrusters and enters into orbit around Venus. Using newly developed synthetic aperture radar, Magellan sent back mapping data, which high-speed computers have turned into a synthetic flyover. Our flight begins with a view of Sif Mons, a volcano 1.2 miles high. We fly over a rift valley, several craters created by meteorite impacts. Gula Mons, another volcano, this one nearly 2 miles high. Our final view is of the northeastern side of the Isla Reggio Highlands. In 1978, Pioneer Venus visited with less sophisticated radar aboard. Pioneer Venus also carried instrument-laden probes to examine the Venusian atmosphere. The mothership releases sounders which will penetrate the atmosphere and then parachute to slow the landing speed. The atmosphere quickly becomes like a steamy soup. Droplets of sulfuric acid eat at the probe's skin. As the probe lands, it is being crushed by atmospheric pressure 90 times that of Earth. The atmosphere also creates colorful auras and rippling landscape effects. With a surface temperature of 900 degrees, Venus is the ultimate runaway greenhouse. This could have been the fate of the Earth had we been located a little closer to the Sun. Pioneer Venus discovered holes in the cloud cover near the poles. This time-lapse photography shows the changing shape and location of the holes, which are never visible from Earth. Ishtar Terra has an elevation equal to the Tibetan Plateau, but covers more area than the US. We have good reason to believe that Venus is covered with active volcanoes that help to spew lava and various corrosive chemicals into the atmosphere. On Venus, it rains sulfuric acid, which quickly turns to steam, a deadly inferno straight out of Dante. The Soviet probe Venera 9 actually survived long enough on the surface to take these pictures. Even as Magellan completes its highly successful mission, future probes are planned. In Venus, we have an example of a planet where something went wrong. Could the same thing happen to our home world? The answers lie out there, sunward of Earth, on the planet we once called the Morning Star. Mercury is the nearest planet to the Sun. About 13 times each century, this small world appears to cross the face of the Sun as seen from Earth. These rare transits of Mercury should never be observed directly, or damage to the eye will result. The Sun is a seething cauldron of hot gas, mostly hydrogen. This solar flare is like a giant explosion in the Sun's atmosphere. Solar activity is ceaseless, as this time-lapse motion picture shows. A solar prominence which dwarfs the Earth in size and represents more energy than humans will use in 10,000 years. Mercury was formed from the solar nebula about 4.6 billion years ago. Its early history was marked by a violent cratering. This heavy bombardment caused molten lava to rise up from deep inside the planet and cover the surface. Another era of cratering and surface cracking gave Mercury its mottled appearance. The jagged terrain sits lifeless, with a glaring sun dominating the sky. Between 1973 and 1974, Mariner 10 made 3 flybys of Mercury, providing the best pictures ever obtained. Those photographs showed craters within craters within craters, a most inhospitable landscape. In addition, Mercury is continuously bathed by deadly cosmic rays. The possibility of life existing on this spare world is almost inconceivable. Although it looks a little like the Moon, there are major differences. Mercury lacks the great maria, or seas of rock, found on the Moon. Also, Mercury has a large iron core, which accounts for about 70% of its mass. One distinguishing feature, the Caloris impact basin, looks like a great bullseye, over 1,300 kilometers across. Mercury boasts the highest range of temperature in the solar system. On the Fahrenheit scale, its sunward side bakes at 700 degrees, hot enough to melt lead, while the dark side chills at more than 300 degrees below zero. The day is 59 Earth days long. Because Mercury has not been weathered by a thick atmosphere, it remains a pristine example of the early solar system. Perhaps we shall revisit Mercury in the 21st century. The outer solar system. The realm of asteroids, comets, ice worlds, and gas giants. A close-up of Halley's Comet. In the year 2000, a spacecraft named Krafft was to have rendezvoused with Comet Kopf and buried a probe beneath the surface. This will not happen. The mission was scrubbed due to a lack of budget. That will not be the case with the unrivaled giant of the solar system, mighty Jupiter. In 1995, the Galileo spacecraft will approach Jupiter. It will first fly past the ancient moon Callisto. Then its larger cousin, Ganymede. And the ice moon, Europa. All in all, Galileo will make 11 merry orbits of Jupiter and its moons. If its high-gain antenna can be made to work, it will transmit the best photographs we've ever seen of the Jupiter system. Galileo is also programmed to fire a probe into Jupiter's atmosphere. Until it is crushed out of existence, the probe will send back vital information about the emperor of the solar system. This is a time-lapse movie of Jupiter and its moons as photographed by one of the Voyager spacecrafts. You'll notice Io and Europa zipping through the picture. Jupiter's axis of rotation is offset from its magnetic pole. Its very high gravity is able to strip ions of sulfur from the surface of Io, creating a torus, or donut of ions surrounding the planet. Here, we're imaging Jupiter's huge magnetic field. The rings of Jupiter, invisible from Earth. Voyagers 1 and 2 gave us some magnificent close-ups of Jupiter's turbulent atmosphere, including the mysterious Great Red Spot, an anticyclone 4 times the size of Earth that has persisted for at least 200 years. Io transits across the face of Jupiter. The pull of Jupiter's gravity on Io's molten interior causes almost continuous volcanic activity. Io is always resurfacing itself. Here and there you can spot a lava lake. The polar highlands are quite spectacular in and of themselves. The work of the computer and space artist combine to provide a sight never beheld by humans. Io eclipses the sun, as seen from its sister moon, Europa. Europa is covered by a frozen ocean. Some scientists believe liquid water may lie below the ice. Cracks in the ice are probably caused by compression. This is Jupiter's largest moon, Ganymede. Its most interesting feature is the unusual terraced terrain, which gives way to fields of craters. The outermost of Jupiter's large moons is Callisto. From Callisto's dark, aged surface, Jupiter and its satellites look like a miniature solar system. Our stop at Callisto ends with a view of its great impact basin, Valhalla. Now, on to Saturn. Saturn, its rings and moons, perhaps the most magnificent sight in the entire solar system. This interaction of gravity and mass has created a unique portrait, the clockwork of the cosmos. Saturn's imposing ring system appears as transparent as gossamer when seen from directly above or below. This is an extreme close-up of Saturn's atmosphere, a picture quite impossible to obtain with any earthbound telescope. 2 Voyager spacecraft were sent to Saturn to help us understand its mysteries. Here, Voyager measures light from the star Delta Scorpii to help compute the size of ring particles. Voyager also discovered and imaged dusty triangular spokes extending radially along the B-ring. And now, a procession of Saturn's larger moons. Mimas, with its giant crater Herschel. Tethys, a moon with a crater large enough to hold Mimas. Dione has bright radiating patterns on one hemisphere and a cratered surface. Enceladus, with its great plains of ice. Iapetus' dark side contrasts the lighter trailing hemisphere. Hyperion, an apparent fragment from the shattering of a larger moon. Titan, larger than the planet Mercury. It supports its own atmosphere. If all goes as planned, the Cassini spacecraft will arrive at Titan in the year 2002. A smaller probe will be deployed into Titan's atmosphere with a landing package attached. What will we discover on this great adventure? Perhaps lakes of liquid methane, Imagine for a moment you are in a spacecraft that will cross Saturn's rings. Perhaps you try making for one of the gaps. What an awesome sight awaits you. Ring systems form when moons stray too closely to a planet and are destroyed. Rings are also made from small chunks of rock and ice that form too near to a planet to become a moon. Voyager 2 shown arriving at Saturn. Ring particles, if left to themselves, would tend to separate. Shepherd moons, Prometheus and Pandora, help keep Saturn's F-ring in place. The rings of Saturn are composed of thousands of individual ringlets. The complexity of their structure is unmatched in the solar system. The computer imagines Saturn as seen from the surface of Mimas. Then rotates the moon to provide the view from its great crater, Herschel. Voyager 1 departed Saturn in 1980. Its course would take it through unknown space north of the solar system. Voyager 2 in 1981 took a gravity whip, propelling it towards its next planetary encounter, Uranus, 4.5 years away. If the Saturn system can be described as complicated, then surely Uranus and its moons could be called unusual. Uranus is tipped on its side, its pole positioned about where the equator should be. Then there's the system of Uranian moons. The orbits of the moons are also tipped, leading scientists to believe the giant planets sustained a titanic collision. Here was a gaseous planet with a featureless atmosphere lying on its side with its magnetic field offset from the rotation axis. What next? Next was Miranda, a moon which had apparently been blown apart, then reassembled by the force of gravity. Nothing they had ever seen prepared astronomers for Miranda's tortured landscape. Uranus, with its rings as dark as chimney soot, seemed to give off a soft blue light. Electroglow is a phenomenon of the Uranian atmosphere. Think of it, a planet and moon system apparently born of catastrophe. As Voyager 2 departed Uranus, scientists on Earth wondered if there were any surprises left. There were. At the edge of the known solar system lay Neptune and its great moon, Triton. Beyond it, the exploration of Pluto would have to wait for the next century. This graphic shows Voyager 2's trajectory for the Neptune encounter. On August 24th and 25th, 1989, Voyager 2 passed through the Neptune system. Before arriving at the planet, however, the spacecraft's cameras imaged the distant moon, Nereid, never more than a dot of light in the largest of Earth-bound telescopes. Here is the approach to Neptune, as recorded by Voyager's cameras. Neptune's rotation was measured to be 19.2 hours at the cloud tops, but only 16 hours 7 minutes in the deep interior of the planet. A faint system of rings surrounds Neptune. While in its turbulent atmosphere, winds were clocked at more than 1,000 kilometers per hour. Here are some real-time images of Neptune as received by the Deep Space Network. White clouds called scooters were observed for the first time. Neptune's most striking feature, the great dark spot, is seen here in an equatorial view. The great dark spot is actually a huge whirling tornado in Neptune's atmosphere. The dark spot is so large, the entire Earth could easily fit inside it. One last major photographic mission remained for Voyager. Neptune's largest moon, Triton, the coldest place in the solar system. Voyager discovered that Triton was somewhat smaller than expected, with a diameter of 2,705 kilometers. It also boasted a rarefied atmosphere of nitrogen with a trace of methane. A surface scan of Triton reveals a frozen world covered with cracks and the remains of ancient volcanic activity. As Voyager 2 left the solar system behind, never to return again, it became an ambassador of humanity to the universe. It is expected to pass by the star Sirius in another 358,000 years. We continue out into space, as far as the mind can see, and are reminded that the universe is not merely more than we imagine. It is more than we can imagine.